Hello, my name is Mneze Naomi and my partner is Deborah Atala. Our details are on the screen and I'm going to introduce transformer-based feature extraction. So I'm going to start off with talking about feature extraction. So feature extraction, feature refers to like a characteristic or a key component of something. So features are like characteristics of something. Then extraction refers to pulling or getting like something from its maybe from the main thing, like you extract something, you pull something out or you get something from it. So feature extraction refers to generating meaningful information from data. So yeah, it is extracting meaningful information from data, and this is used in machine learning to help models process data well, because it reduces complexity in data by extracting the meaningful features of the data. For example, if you have like an image and it is having like many things, then you'll have to get out like the meaningful features in order to understand that image very well. So that is the same in machine learning. A model will first get the main features of that image in order to be able to learn from that image. Here we have an example of this image that is having a border, or a bike. So this image, you use a feature extraction algorithm to get the meaningful or the key features of this image in order for a machine learning model to learn from this image. So when you put a feature extraction algorithm, these are the features that you're going to get. So this algorithm is going to look at the key features of this image, and as you can see, the important features of the image we have here: the wheel, we have like the seat. Like it extracted these 9 important features from the image, and then this makes it easy for it to understand the whole image by first extracting the key features and leaving out the ones that are not so much necessary. Then I'll go to transformers. So transformers are deep neural networks that utilize self-attention mechanism to capture contextual relationships from sequential data. So transformers are also used, they are like machine learning models that to process sequential information using self-attention mechanism. So they are machine learning models, and they are designed mainly to process sequential data or structured data. These include images or text. So this keyword that is in this definition, the self-attention mechanism, it is where the model focuses on the important parts of the data at once. So transformers use this self-attention mechanism to focus on the relevant parts or the key parts of data at once at the same time. Like it works in parallel. We're not, for example, if you have a sentence, it won't start from the first word, the second word, the third word. No, it will look at the whole sentence at once, like learn all the words at once, whether it is the first word or the last word. It is going to understand everything like at once in parallel, not in a sequence format. So this is how transformers extract features. So transformers extract features in 4 steps. There is input of data. You input data, like maybe you have an image or a text. So input it in the transformer encoder, because the transformer will be having the encoder and the decoder. So you're going to input data or the text or the image that you have in the encoder. Then it will use the self-attention mechanism to learn from that data that you have input in it. Then if it learn, after learning from it, it will extract the important features, the ones that have relationships. Yeah, it will extract the important features, and after extracting the important features, it will feed them to the decoder, and the decoder will help it to generate the output for that input. So for the encoder, it will work using self-attention mechanism, so it will work in a parallel way. But then for the decoder, it is going to work in a sequential way, like generating data. It will generate word by word. For it doesn't use self-attention mechanism. So the first step is input sequence data, yeah, like a text or image. So you input it in the transformer encoder. It is like a text. Then after inputting it, choose self-attention mechanism. Yeah, the transformer looks at all the parts of the sequence at once and calculates which parts are more important. Yeah, the key important parts. Then the third step is feature extraction. Yeah, here it identifies the key relationships and extracts important features. After looking at all the parts of the sequence at once using self-attention, it will identify the key relationships. Yeah, the parts that relate to each other, and then we extract the important like data from there. Then after extracting it, it will output features. This is the part of the decoder. So it will extract features like for further analysis or like classification or prediction. So here I have an illustration of transformers, like a transformer of natural language processing, like it is translating like a text, or it is having a text. You input a text and it is going to generate a response. So here this transformer, we have a text of hi, how are you? Yeah, here we have a text showing hi, how are you? So it is going to generate a response to this text. So here it is first input in the transformers encoder, and it is going to look at all the sentence at once. As you can see, they are in parallel, like hi, how are you? They are in parallel. So after looking at it in parallel way, like at once using self-attention mechanism, it is going to look at the relationships, like the relationships or key features of this sentence, like how, the way how is related to are. Yeah, so you see how is related to are, so that is going to help this transformer like start to understand the sentence that you input. Then when it reaches to you, you see that you depends on are. So it will, from here it will have extracted the key features. Then it will input it in the transformer encoder. Then the transformer encoder will use this information that it has gotten to generate the response. But for it, it is going to generate word by word the output. So it is going to generate I am fine. Yeah, so it generates word by word, and each step it generates a word until it meets the end, like until it ends the whole sentence. So you can see I am fine, then it reaches the end. Yeah, so we go to when to use transformer based feature extraction. So you can use transformer based feature extraction in natural language processing. You can use it in computer vision. You can use it in time series data. Yeah, as we are going to see. So for natural language processing, here you're having like text that you're inputting, and you want to generate response, you want to generate certain information from the text that you input. So the examples are like text classification, there is sentimental analysis, or language translation, like translating the language. Maybe you're inputting in English and you want the model to give you the meaning of that statement that you have input. Then there is text classification, like classifying text, knowing that this text is different from this one. That is for natural language processing. Then there is computer vision. Yeah, transformer based feature extraction. We can again use it during like in computer vision. So computer vision, this is where it is, as you can hear, vision, it is going to be related with things that are visual, like images or videos. So in computer vision here, you're using the model to understand or to learn patterns of like an image or a video, the key features, and it will also generate the output. Yeah, to generate the certain output from the image that you have or video. For example, object detection, like when you have an image and you want to detect the object, like maybe you have the image, there is a car this side, like the left, and there is like a signpost on the right. So computer vision is going to help detect that this is a car this side, and this car there is a signpost, and it is going to use transformer based feature extraction, yeah, to be able to detect objects in this way. Then there is image classification, yeah, classifying images. Here it is again knowing that this image is not this one, like it will differentiate, it will identify that this is a cat and this is a dog. Yeah, so here again we use transformer based feature extraction to extract the key features that will help us know that this is a cat and not a dog. Then, and the third one is time series data. So for time series data here, transformer based feature extraction will help us like predict trends or patterns over time. For example, predicting prices according to the previous sales that you had in your stock. Then there's also like weather forecasting. Yeah, here you are going to use transformer based feature extraction. So we are going to why should we use transformer based feature extraction. Yeah, so why choose transformer based feature extraction? So transformer based feature extraction, or transformers, they are help to learn complex patterns in data, because it uses self-attention mechanism. So it will extract data information in vectors. So even if the image is too much complex, transformer based feature extraction is best, it works better here. Then there is also, you want to identify long range relationships in data. Here it is again so important to use transformers, yeah, because transformer will help you understand the relationships between features of an image, even if they are far apart from each other. For example, one is the other extreme end and the other one is the other extreme end. Like when you have an image that is having a car in the road and a signpost this side. So transformers will help us understand that this car is going to take the instructions from the signpost, even if they are far apart from each other. So it is going to show the relationship between these two images, between these two features in the same image. So it works well again on large data sets. When you have large data sets, for example, complex images or complex text that are so big, yeah, it is important here to use transformers or transformer based feature extraction to capture complex relationships. Yeah, and again you have, especially when data especially in data with long range dependencies. Yeah, so my next colleague is going to present about the next part of transformer based feature extraction. Thank you.
My name is Atala Deborah. I'm going to continue with transformer-based feature extraction. So to understand transformer-based feature extraction, we are going to use, it involves using transformer models to enable us to extract features from our data. For example, text data, audio and image data. To start with, have a code extract for extracting features from text using the BERT from the Hugging Face. You can decide to use any model that can help you from any website or any platform. So using this as an example, one has to first install Transformers library from the Hugging Face platform, and then on doing so we see that we have to load the pre-trained BERT model. Since these transformer models are pre-trained models, means they have worked with datasets before. That means they have been trained on other datasets. So we are going to just use them to help us with our data as well. So we have the tokenizer and the model, which are as well going to help us with extracting. This is an example of text feature extraction. Here we are going to be able to see how text is extracted using this pre-trained model. So for our code, we tokenize the text by entering the text. It could be one sentence or even many more sentences, and we need to pad those sentences and truncate them in case they are really long sentences. And then to extract the features, we use the with torch. No gradient is used since you're not training the model, but you're just using it to work with your data. And then for the output, we shall have output in form of the batch size. Batch size is the number of sentences you have input. For example, you have one sentence, which is our text, and the sequence length is the length of that text data you have. And so for this case, if the model is working with tokens in this case, it's going to be one word or a sub-word, like a big word is divided into two words, or even a character like a full stop or an exclamation mark is taken as a token. So this model is going to divide this sentence into different tokens and analyze each and every token so that it can contextualize and come up with a relationship or a given pattern for this text. And later we shall see where this is applied in the day-to-day life. Then moving on to feature extraction for images. This is another code extract. So we are taking the transformer model as the Vision Transformer VIT, still from the Hugging Face. Still need to download the Transformers library and the PIO library, which helps us to work with images. And you see that for this case we have the pre-trained VIT model and the feature extractor, which we actually get from this platform which you have decided to use. And then first of all we need to load the image. Open the image that you want to extract features from, that you want to work with. And then still extracting features, we use the with talk. No grad is used to let the model know that you're not training it, but you're just using it to help you analyze your images. And so for the output, we see that this model is going to be able to also tokenize the image. So the image is going to be divided into equal portions or patches, and this model is going to analyze one patch by one patch so it can determine the relationship between these different patches of a given image. And then for the batch size as our output, we shall have one image. Since our input is one image, then our batch size will be 1. And for the num patches, that's the image patches I've talked about, how many patches the image has been divided into for analyzing. And then we also have the hidden size, which is set by default, which is 768. And then another code extract for sound. Since transformer-based feature extraction is also used to help one analyze sounds. Sounds like audio form. It's not very different from the image and text processes. So in this case, you're going to as well load a pre-trained model that works with sound, because there are different transformer models for different type of inputs. So we load our audio file. We see audio path equals sample audio.web. We load the audio file and then process the audio. And then for our output, still the batch size, we shall have 1 for one audio path. If you have more, there will be more. Sequence length, we see that this audio is going to as well be divided into different tokens, different portions, so that each portion is analyzed differently, and then a relationship is determined from all those different portions of the audio that have been extracted from the given audio. Moving on to advantages of transformer-based feature extraction. For the case of audio, these transformer models that we work with in this case are able to handle variable length inputs, in that they will handle short pieces of audio and the same way they handle the longer pieces of audio, to help the user analyze and be able to obtain information, like the required information they want from this given audio they have input. And also, still in the case of audio data, some transformer models that are used in this case are able to distinguish, since they are pre-trained, they can enable one to distinguish between languages in a given audio piece. And also, since they are pre-trained, we see that they are speaker agnostic, in that they can differentiate different, they can help to categorize voices into different classes, different speaker voices. And then another advantage is that they are scalable. These, in the case of images, for using Vision Transformer as a transformer model, you see that it actually outperforms the traditional models like CNN, because it's scalable. Since this model is usually trained on large data sets, if you come across it and you want to use it on your large data set, it's going to work well for you, even with small pieces of data. Unlike the traditional models of extracting features, they usually work well with smaller data sets. And then moving on to capturing global dependencies. Unlike the traditional models, these transformer models, these transformer-based feature extraction models analyze each and every detail in a given image of a face. They are going to analyze the eyes, the nose, the mouth, ears, and put everything together to come up with the face of a given individual. And then in the concept of context awareness, they are able to capture meaning of data based on the concept. For example, if you are working with text data and have examples of money in the bank and the river bank, the transformer model is going to be able to analyze that this bank used in both cases is used for different meanings, or So to continue with the advantages of using these transformer models for feature extraction, these models are pre-trained models in that they've already been used on other datasets and have been trained on what to do with different pieces of information. Then moving on to the challenges of using these transformer models for extracting features. We have high computational cost and large storage requirements. And as we've seen that these models usually work well with large data sets, we are going to require large storage for those large data sets, and also computational cost is going to be relatively high in that we have to have a lot of space and computing capacity on our machines. And also the output usually of these transformer models is difficult to interpret by humans, because we see that they are going to determine relationships with this data in many different ways, and therefore for a human being may be hard to understand the concept if they have not focused on what's really happening. And then we have bias in training data. Someone can come across a transformer model that has been trained with a large data set, and during the training might have developed bias while working with a given piece of data, and therefore may result into inaccuracy as someone uses it for their given data. And then you see that these transformer models are usually sensitive to noisy environments. To give an example, someone working with audio data, this data could have like interruptions, could have background noise, and all this is going to affect how the model they've chosen to work with is going to affect the output and the accuracy of the output they expect from using this model. And then we have slow training and inference. These transformers are usually slower since they are using this attention and self-attention mechanisms where they have to contextualize and determine relationships within the pieces of data given, so that they are going to be slow in the training of this new data set. And then for the real-world applications, we have the facial recognition that can be used for security purposes, whereby these models are incorporated into these mobile applications, into different systems, to help extract the patterns, the features, the relationships in, say, an image for a given person. And then we have chatbots like the ChatGPT which we use in our everyday life. Once someone inputs text in the search bar, these chatbots have these transformer models embedded in them to extract this information and use the self-attention and attention mechanism to contextualize data in a given context and after doing so they determine the relationship and then provide someone with the output, that with specific output to what they asked this chatbot or the virtual assistant. And then there is sentiment analysis and opinion mining. This can be used for product reviews. For example, reviews on an application that has been created in a way that, for example, using the BERT, the BERT we saw in the beginning, if it's incorporated into these mobile applications, it's going to be able to classify, say, for reviews on a given product, it's going to classify information that's provided by people for maybe improving the product, maybe removing of bugs. It's going to classify them and mine them so that there is no need for manual work to be done reading through each and every text that's been given. And then we have music and sound classification. So in using the transformer based feature extraction models, we can be able to, in case we have audio data, we can be able to classify, they can enable us to classify music from different instruments into their different classes. For example, using Shazam, while using Shazam, it's going to require you to sing into your phone, and while you sing, you're going to see that it's going to give you an output of the song that you're requesting for in text format. So we see that these models are incorporated in a way that they are going to analyze and determine the relationship in the data you're feeding into this model to give you what the output that you're expecting, in that they extract features and determine relationships, draw patterns, and determine context, contextualize. Then for the case of using images, you see that these models are used in medical imaging and disease diagnosis, since we have seen that they analyze each and every piece of a given image. Analyzing, they determine relationships from these different pieces of information on the image that's been given, and then come up with a conclusion. Then for recent studies, I came across this transformer based feature extraction method. That it's a study that was done to enable these people that develop applications, to help them in a way of the reviews that they get from the users, that they can categorize them and classify them to enable them to probably to read through them faster without having to do it manually, so that if it's about modifying their products, they can do so. So the key contributions of this study were to do with feature extraction, and that they did research and found out that these pieces of text, these reviews that are in form of text, can be extracted in their context, or say text that has the same words can be classified into say bugs. If the issues are about bugs, they can be classified into bugs. If it's about product improvement. And then another contribution was the transformer based natural language processing, in that if someone really wants to not do the reviews or the reading of reviews, or going through the reviews manually, they will have to incorporate these transformer based models to also help them with maintaining their software without using too much resources, and also automation. This method was able to, this research was able to discover that this reviewing of the reviews, going through the reviews by these developers, can be done automatically with the help of the transformer models for feature extraction. And then this the reference to the recent study. That is it. Thank you.